All right, let's look at the warm-up. I know most of you got it done and you had it correct, so it should not take us too long to get through this warm-up. Number one, what's the formula for area of a triangle? Someone raise your hand. Tell me, James. Base times height divided by 2, or you could say 1/2 times base times height. So 1/2 times 4.3 times 10. And you get 21 5/10. What's our units? Inches squared. That's all there was to that problem. That is a 6th grade problem all day long. All right, 2. Find the area of the shape below. Break the larger shape into smaller pieces if needed. So we've got this composite figure. What is it if we close it? It's a net for what shape? Anybody know? A square pyramid, right? Because if it just has one base, one square base, it's a pyramid. Okay. So what are the shapes that we have? 3 triangles and a square? 4 triangles and 1 square. And the 4 triangles are all the same size. So for the triangles, we're going to say 1/2 times 5 times 4.1. One-half times 5 times 4.1. So each one of these is 10 and 25/100ths. This one right there is 10 and 25/100ths. So 10 and 25/100ths times 4 is 41. So the area of all of those together is 41. And then the harder part to me is the square in the middle. What am I going to multiply together for the square in the middle? Someone raise your hand if you can tell me. Marcus. 4.1 squared, or you could say 4.1 times 4.1, which is the same thing as squaring it, right? And you're going to get 16.81. And so you'll add it to that. And you get 57 and 81/100ths inches squared is your answer. Questions about that problem? All right, 3. Joe is placing tile in a small rectangular room. The room measures 8 feet by 5.5 feet wide. If 1 square foot tiles are sold in packages of 12, how many packages will he need? So what's our first step on this problem? Aiden Morrison. 8 times 5.5, because I need to find the size or the area of the whole room. And we get 44. It's 44 feet squared. Now, you're going to go to Home Depot and you're going to buy packs of tile and you get 12 square feet. So each pack of tile is going to cover 12 square feet. So you can either, what math could you do? Divide. Or if it was me and I was sitting there and I would go, well, 1 covers 12, 2 covers 24, 3 covers 36, so we're still not enough. And 4 covers how much? 48 square feet. So what would I need to buy, 3 or 4? 4. You'd need to buy 4. And then in real life, what would happen would be you would have 4 tiles left over. You would put those in a closet or in the garage. And then later, if somebody drops something and cracks a tile, guess what you do? You go get the tile from the closet and you replace it. That's real life, people. So you need to buy 4 packages of tile. questions about any of the warm-up? No? Okay, put it up and let's look at the tree diagram paper. Tree diagrams. So we started yesterday with an introduction of tree diagrams. So close your Chromebooks if you have them opened. And let's look at this page. You've got to learn how to read tree diagrams. You've got to learn how to make some tree diagrams. So this is not a splitting your attention. This is a new skill that you are learning. Okay. Everybody got their paper? A tree diagram is a branching diagram that shows all possible combinations or outcomes of an event. That's your vocabulary word. Outcomes. That's a word you need to know. So it shows all possible combinations or outcomes of an event. So what are the outcomes for spinning this spinner and then tossing this coin? So if you're playing a game and you had to, on your turn, spin this spinner and toss this coin, what are the possible outcomes? So what are your possible outcomes for this spinner? So you could either land on yellow, green, blue, or red. Those are your possible outcomes. So how many possible outcomes are there on this spinner? 4. There's 4 possible outcomes. And then if you flip this coin, how many possible outcomes are there? 2, heads or tails. And so what we learned yesterday is that we can figure out how many possible outcomes there are. If there's 4 here and there's 2 here, 4 times 2 is 8. So there's 8 possible outcomes. So we're going to look at what math comes up. So list the possible outcomes for the first event. So red, yellow, blue, or green. That's event 1. Your outcomes are red, yellow, blue, or green. List the outcomes for the second event. So the outcomes are heads or tails. So we're going to use these outcomes to make a tree diagram, okay? And they want us to list our tree diagram sideways like we did yesterday. That's not the way I prefer to do it. I prefer to do it top down. But we're going to list our outcomes of our first event here. So we have our first is red. The second is yellow, blue, and the last one is green. So then the outcomes of the second event. So if I spin this spinner and it lands on red, then I flip the coin, the 2 possible outcomes are heads. Or if I spin it and get red, the next outcome is tails. All right. Next time, if I spin and I land on yellow, that's the first thing that would happen. And then when I flip the coin, I'm either going to get heads or tails. So how many outcomes am I up to now? 4. 1, 2, 3, 4. So then, if the first time I spun that, I got blue, and then I flipped the coin, what are my 2 choices? Heads or tails. And then the last one, if I spin and get green, then my next outcome are heads and tails. So then we need to list our sample space. So if there's 8 possible combinations or outcomes in our sample space, how many things should I have listed? 8. So you could get red heads, red tails. Yellow heads, yellow tails. Blue heads, blue tails. Green heads and green tails. That's what your sample space should look like. Anybody have questions about where that sample space came from? It just came from each one of these. Yesterday we highlighted red and heads, red heads. Red tails, red tails. Everybody good with that? Okay. Let's answer these questions now about our tree diagram. How many possible outcomes for spinning this spinner and tossing this coin? There are 8 outcomes. What is the probability of the outcome spinning a blue and getting tails? So, what do you think, Elijah? 1/8. That's going to happen 1 time out of 8 times. Blue tails is only once, 1/8. What is the probability of the outcome spinning a red or green and getting tails? So, a red or a green and tails. There's a red tails and a green tails. So that is 2/8, or simplify it to 1/4 would be your answer. 1 time out of every 4 times that you spin this and flip that, 1 out of every 4, you should land on a red tails or a green tails. You okay with that? Seems pretty easy. Okay, so on the back, you are going to make your own tree diagrams. List the sample space. Tree diagram, sample space. All right, so do you want to see a tree diagram going from the top down instead of the side over? Because you've got to be able to read them both ways. So let's do number 1 together. A restaurant serves white toast or rye toast. That's your first possible choice right here, 1. Then you can either have jam, butter, or cream. So that's 2. That's your second choice. How many different ways can you do that? So you can start with toast or rye. Everybody okay with that? Oh, it's white. White toast or rye. And then you can either have jam, butter, or a spread. Then on the rye, you could either have jam, butter, or a spread. So how many different ways can you, how many different outcomes are there? How many? 6. So there's 2 here and 3 here. 2 times 3 is 6. Let's list a sample space now. White with jam, white with butter, white with spread. All right, so if you don't have any questions, you are going to do 2 and 3 on your own and turn this in before you leave. Let's look at the other paper. All right, so let's look at this other sheet, the fundamental counting principle. Use the fundamental counting principle to find the total number of outcomes in each situation. You already know how to do this fundamental counting principle. That's what we did yesterday when we just multiplied the outcomes. So the fundamental counting principle just means that you multiply all the different things together. So, number 1, rolling 2 number cubes and then tossing a coin. So what's a number cube? A dice. How many sides are on a dice? 6. So there's 3 different events happening here. So the first time you roll a dice, how many outcomes are there? 6. You're rolling another one. So the next event, there are 6 outcomes. And then tossing a coin, how many outcomes are there? 2. So, rolling the first dice, there's 6 outcomes. The second dice, there's 6 outcomes. Flipping a coin, there's 2. 6 times 6 is 36. 36 times 2 is 72 outcomes. That's what you do for the fundamental counting principle. Choosing rye or Bermuda grass and 3 different mixtures of fertilizer. So the first event is you're choosing the grass. So how many outcomes are there? 2. And if you choose from 3 different kinds of fertilizer, how many outcomes? 3. 2 times 3 is 6 outcomes. Easy enough? All right, some of it's difficult when you get down here. You have to know how many days are in a week. Most of you know that is 7. A date in the month of April. You need to know how many days are in April. Is it 30 or 31? So, when I was younger, I learned a rule. So, if you put your left hand out in front of you. All right, start with this knuckle of your index finger. That's January. There's 31. February, there's not 31. March, there's 31. April, there's 30. May, there's 31. June, there is 30. July, 31. And then you start back here. August also has 31. September's 30. October's 31. November is 30. December's 31. So every time you're on the top of one of your knuckles, you're at 31. I don't know if that'll help. You could also use a calendar, but they're not always handy. When I was little, I didn't have a cell phone with a calendar on it. So, but you needed to know, I think April has 30 days. All right. I think you're going to be okay on the rest of these. So if you have a question, come see me or Coach Baker or Mr. Millwood when he's in the room. Otherwise, just go ahead and get started and turn in both papers before you leave. All right.